Hi everyone, I'm Xitong from Meta AI Research. I'm going to introduce our work Relational Space-Time Query in long-form videos. Egocentric videos, commonly captured by wearable glasses, are often found in the form of uncurated, long-duration recordings. In order to comprehend these videos, an AI model should be able to not only recognize the activities and objects within the videos, but also crucially reason about the interactions and relationships among them. In this paper, we propose relational space-time query, which bundles the analysis of human activities, objects, and their interactions into a unified framework. We also introduce two novel benchmarks that enable the joint evaluation of these problems on public egocentric datasets. Finally, we provide a series of baseline experiments aiming to gain valuable insights into the task. Computer vision research has witnessed remarkable advancement in recent years. While numerous models and benchmarks have been developed to tackle individual tasks, there has been very limited work focused on studying the interplay and interactions among different vision problems. For example, action recognition, object detection, and hand-object interaction are typically treated as separate research areas and evaluated using different datasets. However, we argue that a joint analysis of activities, objects, and their interactions is crucial for understanding long-form egocentric videos, considering their inherent complexity in human-object interactions. Therefore, the development of a new integrated benchmark for long video analysis is highly desirable to support the future model development and evaluation. Towards that end, we introduced Relational Space-Time Query, an integrated framework that enables the unified evaluation of activities and human-object interactions through the use of templated queries. Specifically, we first describe an event in egocentric videos using the following form. I'm engaged in some activities while interacting with some objects during some time. By formulating queries as inquiring about one of the three key properties in the template, we can construct the three fundamental types of REST queries: activity query, object query, and time query. These queries impose the requirement for the video model to effectively capture and understand the interplay between the two given properties simultaneously. For activity query, the goal is to predict a subset of predefined activities given the query object and time window as input. Note that the query objects are represented by image crops instead of language descriptions, which is more precise and concise when referring to a specific object instance. Unlike conventional activity recognition and detection tasks, activity query incorporates additional conditions on human-object interactions, which makes it more challenging and less ambiguous when applying to long videos. For object query, the goal here is to predict spatial temporal locations of all interacting objects while the query activity is being performed in the time window. The query activity is represented using categoric IDs instead of language description. Finally, for time query, the aim is to predict the temporal segment of the query activity while ensuring that the query object has been interacted with within the segment. To summarize, we propose three types of REST queries that necessitate a joint understanding of both activities and human-object interactions in order to generate the correct answers. More complex queries can be constructed by combining the basic ones or incorporate additional properties, which will lead to future work. To evaluate the REST query, we introduced two new benchmarks based on the public datasets ADL and Ego4D. Both datasets consist of egocentric videos with long durations and are characterized by intensive human-object interaction. In particular, the REST ADL benchmark is smaller in scale but provides denser and cleaner annotations, making it more suitable for task analysis. The REST Ego4D is larger in scale and more challenging, with videos recorded from diverse scenarios. It's worth noting that we connect annotations in a bottom-up, semi-automatic manner, where we first collect dense, low-level annotations such as activity segments and object bounding boxes, and then proceed to automatic query generation. This enables better control over generated queries and improved data efficiency. For example, the average number of queries per hour for our benchmarks is much larger than that in the existing work. Solving these REST queries requires understanding of both fine-grained human-object interaction and long-range temporal dependencies in videos. To achieve that, we first develop a simple, modularized system that generates answers by consolidating predictions from multiple perception modules, such as interaction module, embedding module, and activity module. Our modularized system first estimates the likelihood of a time step being relevant to the query task, indicated by the orange curves in the figure on the right. Then, the system consolidates prediction results according to the relevance likelihood to generate the final answers. We evaluate the effectiveness of baseline models using the standard metric we call @kx, which measures the percentage of ground truth labels identified in top kx predictions. We report baseline results on REST ADL and REST Eagle 40 for different query types. Our REST tasks are highly challenging, even with state-of-the-art perception modules. We also conduct sensitivity analysis to understand the impact of each module to the overall REST task performance. We observe that the activity module is critical for all types of queries, while the object detection and interaction modules have larger impact to object query. Thanks for listening. Please scan the QR code to access the latest version of our benchmarks and codes. Welcome to stop by our poster for discussion.